I'll make a hole like this. In the side wall, in the slant face, I'll make a hole so that everything is filled up. Now look at the container. It's a conical, no? Look at the walls. Walls are inclined. So now we are trying to analyze what will happen to the liquid. How do it emerge? Yeah. So the liquid, what will happen? The jet. So this angle, let it be theta. So the liquid here will emerge like this, and it will similar to projectile projected from a tower at an angle theta. The same conditions is what will come. So the velocity of efflux should be directed normal to the wall. If this is theta, this should be theta. Am I right? Theta. So no, I'll call this is length L. The hole is at a length L. So we know theta. Can we calculate the depth? Depth at which the hole is made. So what is the depth here? So depth, this should be h, no? So from the mathematics, so what we can write it as? This is L, this is theta, this is h. So sine theta is equal to h by L. So what is h equal to? L sine theta. What is the velocity of efflux first? 2gh, 2gl sine theta. Agree this? Okay, after this, what will happen? It will be a projectile motion. So what is the total height of the cone? Let it be capital H. So what height it will descend? Capital H minus small h. The remaining height it will descend. Capital H minus small h is equal to V cos theta t minus gt square by 2. With this, we'll come to know what time it will take to come and strike here. The jet will strike with certain speed v1. Then what horizontal distance it will traverse? It's a pure projectile, huh? Nothing to do with anything. So this will become range. This will become range. So what is the range? Range should be equal to V sine theta into T. How the thrust force will act? The thrust force must act in this direction. So what is the thrust force? Rho A V square. What is A? Area of cross section of hole. Getting the idea now? So the how the velocity will be directed normal to the slant face. And the thrust force should not be horizontal, opposite to velocity of efflux. That's the basic rule. Okay, now let me make the container. Small observation, nothing. Let's take this condition. I'll construct it. Meanwhile, you can, this is the container. Now the same conical container, the broad side is made open and the narrow side, what happened will be placed on the horizontal surface. So we'll make a hole in this container. So let that hole be at a See now the liquid what will happen will emerge normal to it. That's the same ideas. So the jet what happen will come and strike the ground. I think just now previous earlier one problem we did know that the similar idea of that. Let H be the this one. So let's take this is again the same theta. Let it be at a L, at a distance L. So we can calculate at what depth the hole is located. This will be the range, range of the jet. Let's get into mathematics. So from the triangle, this is theta, this is h no. So what is sine theta? Sine theta equal to h by L. H equal to L sine theta. What is the velocity of efflux? 2gh, 2g L sine theta. Shall I write directly? No need of Bernoullis theorem directly because it all depends on depth, no? No, not length L, slant length L. Vertical depth, the hole at what vertical depth it is located. Pressure depends on depth, no? From that we are deducing this one. Now, if this is theta, this will be theta, 90 minus theta. So this will be theta. Then h minus h should be equal to v cos theta t plus g t square by 2. Solving this, we'll get the time. After getting time, the range will be v sine theta into t. How the thrust force? The thrust force will act normal to this. A be the area of cross section hole. No, you look at the normal contact. Normal contact will be different. No, both the cases, the weight of the liquid is same. Here, component of thrust force will act vertically up. Previous problem, the component of vertical force will act vertically down. So definitely the normal contact experience will be different. So can you manage now different shape container?